Hi there. I have a lesson dealing with the real number system, and what we're going to do is we're going to take a look at classifying all of those different types of real numbers, and there's many of them. And to help us with that, I created a flow chart here to kind of give us an idea of where all of these numbers fit in. So real numbers are all of those numbers that can be either rational or irrational. It's putting all those two groups together. But what is a rational number? Well, a rational number is anything that can be written as a fraction. So that's kind of self-explanatory. We can have a number like 4/3. That's a rational number. Now, some other things, though, that are also rational are decimals that terminate. Now, what does that mean? Well, that means something like 0.25. That can be turned into a fraction. Many of us know that that is 1/4. But notice it terminates. In other words, it stops. Other decimals that we could have would be repeating decimals. I like 0.3 repeating. Many of us know that that is 1/3. It can be turned into a fraction. But those aren't the only ones. I also look at repeating decimals as maybe something like 0.12. That repeats. So it just goes 0.12, 12, 12, 12 over and over again. That is also an example of a rational number. So as long as you can write it as a fraction, it is a rational number. But again, terminating decimals, like the 0.25, those are rational numbers as well, and anything that repeats with a pattern, okay? 0.3 repeating, 0.12 repeating, goes on forever and ever. Now, those are the rationals. Let's just go to irrational then. Irrational numbers that cannot be written as fractions. If rational means you write it as a fraction, irrational means we cannot write it as a fraction. Some examples of that would be one of my favorites, the number pi. 3.1415926, and it just keeps going and going and going. That is an irrational number. Some other things that we looked at would be when we worked with square roots. The square root of 2. 2 is not a perfect square, therefore when you take the square root of it, you don't get a whole number or an integer. You just get 1 point something, 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 and it just keeps going on forever and ever, and it does not repeat. So therefore, it is an irrational number. And there are many irrational numbers to look at, but I just gave you 2 examples. Now, let's go back over to the rational side again, and let's look at integers. What were the integers? They're all the whole numbers and their opposites, meaning I'm going to start with, we'll go -4, -3, -2, whoops, forgot the negative, -1, 0, and then 1, 2, 3, so on and so forth. And this keeps going on forever that way, but it also would keep going this way. So those are all the integers. The whole numbers, those are all those numbers that we count with, along with 0. Get rid of that. So our whole numbers would be 0, 1, 2, 3, and that just keeps going. And then the last group that I have are the natural numbers, which many times are referred to as the counting numbers. And we have our 1, 2, 3, 4, 5, so on and so forth. So those are all of the different groups that we're going to take a look at under the real number category. Now, the next thing that we're going to look at is another way to interpret that previous one. I look at it in a Venn diagram. So the real numbers, the big purple one, that incorporates everything. So everything is inside the real numbers. Then you have your irrational numbers. I'm going to start with those. They're kind of this little group all by themselves, remember, cannot be written as a fraction. And then we have our rational numbers, which can be written as a fraction. So that's everything else that is involved. Integers can be written as fractions. Whole numbers can be written as fractions. Natural numbers can be written as fractions. So they're under that rational heading. Now, I have some problems here that just encompass naming the different kind of numbers we have. Now, what I would like to do in this case is I'd like to go back to this page to help us out. So the square root of 36 we look at is really the same thing as 6. So I'm going to take this square root of 36, I'm going to bring it over here and go, well, where would that fall under? Well, the square root of 36, is 6. 6 is a number that I count with. That's a natural number. It would go right there. So now I have to name all the different numbers that the square root of 36 is. Well, since it's in the natural number little ellipse, I know it's a natural number. But the square root of 36 is also inside the whole number little grouping, so I have to bring that one over. Maybe, there we go. Whole numbers. But it's also inside the integers. It's also inside the rational numbers. And the rational numbers are also inside the real numbers. So that square root of 36 is all 5 of those different, it could be classified under all 5 of those groups. Now, let's take the negative square root of 20. Negative square root of 20, well, the square root of 20, 20 is not a perfect square, so that's going to have to fall under the irrational over here. Well, that makes it an irrational number. Where did it go? I lost it. I don't know. Let's see if we can have any technical difficulties. All right, we're back. So it's irrational, but being it's in the irrational ellipse, that means it also has to be a real number, so I can bring the real numbers over here, and that would be it. So this negative square root of 20 is irrational, and it's real. Now I have this number 3, the point, there's 0.147147, notice, and then it says dot, dot, dot. That's to represent that it just keeps going on, and it's following this pattern of 147, 147, 147, and hopefully I've given it away when I said 147, 147. That is going to fall underneath, it's a rational number, because it is a decimal that repeats over and over again. But it's not an integer or a whole number or natural, so I just put it under the rational heading. Well, we know that it's rational then, but it's also real, because all rational numbers are real. Now I have the square root of 81 over 36. Well, I look at this and go, I should probably simplify it first to help me out. Square root of 81 is 9. The square root of 36 is 6. Both of those are divisible by 3, so in the end, I end up with 3 halves. Where am I going to put the number 3 halves in my Venn diagram? I bring that over, and that's going to be under my rational numbers, or in the rational number ellipse. It's not an integer, so then it's rational, and it's real. Uh-oh, that one got lost. Let's try it again, bring it back over here. There we go. The numbers aren't showing up. I don't need 2 rationals. I already have that one. Let's get rid of that one. This one is very faint. I don't know why. Let's just clone this one. We'll bring that one. There we go. So we have rational and we have our real. And then we have negative 4/5 here. That negative 4/5, that's also going to fall under that rational category. It's not an integer. Therefore, it's going to have to be rational. And it's also a real number. And then I have the 0.79. I just noticed that this rational went away, so let me put that one back there. Some funny things happen with technology. There we go. That one's supposed to be right there. Now let's take the 0.79. This one is also going to fall under rational. It's not an integer or a whole number, so it's just going to have to go right there. And then kind of repeat the process. It's both rational and real, just like the previous ones that we had. So let's just clone that and slide these over. And I've taken the few examples that I have here, and I've classified them under what kind of real numbers are they. And that's going to conclude my lesson on the different types of real numbers.